All right, Algebra 1A students. Welcome to part 2 of lesson 1-9. Today we're going to continue talking about equations with two different variables. And we're going to talk about graphs and how graphs and those equations can kind of work together and how we can represent situations with two variables in very different ways. So let's go back to our example from our last video about Carrie and Kim. They're sisters, and we know that Kim was born 2 years before Carrie, so Kim is 2 years older than Carrie. So yesterday we looked at writing an equation for this situation to represent these two variables, C for Carrie's age and K for Kim's age. And we wrote that from this table. So we have a bunch of Carrie's ages and Kim's ages, Carrie's ages and Kim's ages, Carrie, Kim, Carrie, Kim, Carrie, Kim, and so on. Today we're going to make a graph from this table. Okay, we're going to make a graph from this table from this situation. So to draw this graph, we are going to basically create ordered pairs of x values and y values, or in this case c values and k values, that we can use then to plot this these data points. So the first point that we're going to have is 1, 3. Right? 1, 3. That obviously stands for Carrie's age being 1 and Kim's age being 3. Then we would also have another coordinate point that's 2, 4. That's Carrie's age and Kim's age again. And then 3, 5, and so on and so on and so on, all the way down and all the way along this table, right? X value, Y value, X value, Y value, X value, Y value, X value, Y value, and so on all the way down. So we can take these points and we can start to plot them on a graph. So I have a graph created here with an x-axis and a y-axis. I'm going to put Carrie's ages on the x-axis, and I'm going to put Kim's ages on the y-axis. Now, I did not mark this off at all in the negative direction because, well, it should make sense why, because obviously I cannot go negative in either of their ages. They can't be negative years old, right? And so what I have done here is, let's see, here I have 1, 2, 3, and so on for Carrie's ages. And then for Kim's ages, I went up by 2's here. So I have 2, and then 4, and so on all the way up to 12. Okay, so I can start plotting points here just from these ordered pairs I have on the left, and then I'll keep that pattern going from my table, which is right up here. So what I can do is I can plot my first point when Carrie is 1, that'd be here. Kim is going to be 3, which is going to be right here. So there's Carrie and Kim, Carrie at 1, Kim at 3. When Carrie is at 2, Kim will be at 4, so then we're up here. When Carrie is 3, Kim will be at 5, so we'll be up here. And when Carrie is at 4, Kim will be at 6, and so on and so on. And we know that this can extend for quite some time, and obviously it can start when Carrie is 0. Right? It can start when Carrie is 0, no problem. So I'm going to put a blue line here starting when Carrie is 0 and Kim is 2. I'm just going to extend it all the way up this way, and that's going to cover all of these points. So when Carrie is 7, my Kim will be at 9, and so on and so on. When Carrie is 10, Kim will be at 12, right, which would be right about there. So I now have this line of ages that represents this equation. So as we can see, as Carrie's getting older, Kim is also getting older at a very steady rate, obviously 1 year at a time, right? So it should make sense that our graph here is a straight line, and we're just plotting these points and then connecting them in a straight line here, okay? Because obviously when Carrie is 1.5, then Kim will be 3.5, and when Carrie is 2.8 years old, Kim will be 4.8 years old, and so on and so on. So all these points, this whole line represents all the points that could be in this table. Okay, so I just took these these table values, turn them into ordered pairs, and I graphed a line from that situation. Okay, I graphed a bunch of points and connected them with a line because obviously I can have points in between as well. Okay, so that's one part of your practice problem set. The other part is something that's a little bit different, but at the same time kind of fun, where we are going to look at inductive reasoning. Okay, and inductive reasoning simply means looking at a pattern. Okay, so inductive reasoning, this brand new vocabulary word right up here, is the process of reaching a conclusion based on a pattern. So we look at a specific situation, we notice a pattern over and over and over and over again, and we draw a conclusion based on that. Okay, we draw a conclusion from that. Okay. Now, the question that they're asking us here in problem 3 says there's a table that shows the relationship between the number of blue tiles and the total number of tiles in the figure. So obviously when there's 1 blue tile, there are 9 tiles total. When there's 2 blue tiles, there are 18. 3 blue tiles, 27, and so on. Okay, they want us to extend the pattern and tell them what is the total number of tiles in a figure with 8 blue tiles. Okay. Now, when we're just asked to go up to 8 blue tiles, it's pretty easy just to keep this table going for a little while longer, right? Where we can go 6 blue tiles, and then we can go 7 blue tiles, and then we can go 8 blue tiles. And we should be able to, I hope, find the pattern here as we're increasing our number of blue tiles, what's happening to our overall number of tiles. And as we can see, if we look at our pattern, our overall number of tiles is continually increasing by the same number. We added 9, added 9, added 9, added 9. So over and over and over again, we're adding 9 to the number of tiles every time we add 1 to our blue tiles. Okay, so that's our pattern. Every time we add 1 blue tile, we add 9 total tiles, right? So if I continue that pattern and extend it a little bit further, well, at 6 blue tiles, that's just 9 more than I had with 5 blue tiles. So I had 45 total before. I add 9 and I now have 54 total tiles. Okay, so that's 54. Then going to 7, I'm going to add 9 again, and I'm going to be at 63 total tiles. And then one more time, when I have 8 blue tiles, I'm going to have 72 total tiles. Right? So my answer, of course, is 72 total tiles from extending that table. And that is inductive reasoning, where we just continue the pattern of plus 9, plus 9, plus 9, plus 9, plus 9, until we get up to where we want. Okay. The issue, of course, comes if I asked how many tiles would there be in a figure with, I don't know, 108 blue tiles, right? What if I asked you for 108 blue tiles? Now it's going to take you obviously a very, very long time to keep adding 9, adding 9, adding 9, all the way up till you get to 108 in our blue tiles column. So that's where we use the strategy we had yesterday of actually writing an equation. Okay, when we get very big numbers, it's often helpful to write an equation. Okay, so to write an equation from this table, what we're really trying to do is, instead of looking at the pattern to go from this row down to that one, next one, next one, next one like this, we're actually going to look, how do we go across? Okay, how do we go from 1 to 9? How do we go from 2 to 18? How do we go from 3 to 27 and 4 to 36? Right? And most of the time, we're going to see a linear, or a multiplying, I should say, a multiplying relationship. Not always. Sometimes it'll be adding, but a lot of times we will see a multiplying relationship, which we see here as well. Okay, we see that to go from our number of blue tiles to our number of total tiles, 1 to get to 9, we multiply by 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36, and so on. So we can write this equation that says total tiles is equal to 9 times blue tiles, right? Total tiles equals 9 times the blue tiles. So instead of saying total in blue, I could rewrite that, of course, to just be t and b, so I'll have two variables. Again, we're dealing with equations with two variables in this section. So I could say t equals 9 times b, right? T equals 9 times b. So then if I wanted to find 108 blue tiles, I could just plug 108 in here for b, and then do 9 times 108 and have my answer. I could also do that for 8, right? Because we should know that 8 times 9 would give me my 72. So if it works out well, you can just extend the table, use your inductive reasoning to answer these kinds of questions. But I also want you to practice a little bit writing equations with two variables, comparing one to the other. How did you go from this variable to that one? How did you go from this column to that one? So try writing some equations as well, because then we can plug in for this value anything that we want. Okay? So if you have questions about extending a table, extending a pattern, or writing an equation from a pattern, or making a graph from a pattern or from a table, make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.